Good morning, everyone. My name is Shreya Jariwala, and I am an intern at MorphoBank. And today I'll be talking to you about AI-assisted data transfer, moving data from the paleobiology database to MorphoBank. And so let me begin with the table of contents and give you an idea of what I'm going to be talking about today. So I'll be giving you a slight introduction to MorphoBank. I will be talking about the problems that are associated or that we're facing at MorphoBank currently, an AI-powered solution that I came up with to battle these problems, kind of the mechanics of how it works in the background, future applications, and then I'll be open to questions through email. I'm so happy to be able to present, even if it's virtually. So if you guys have any questions at the end of this presentation, please feel free to reach out to me through email. So let me begin by a little description of what MorphoBank actually is. And so MorphoBank is a powerful online platform that is designed for collaborative research in phylogenetics. This is kind of a part of a larger movement that's known as the fair data movement. It's in order to make data more findable, accessible, interoperable, and reusable. MorphoBank is, of course, an open access repository specifically designed for phylogenetic matrices. So this part of FAIR is just for phylogenetic matrices, which makes phylogenetic matrices findable, accessible, interoperable, and reusable. And so this is a quick overview of the functionality of MorphoBank. So scientists will be able to upload their phylogenetic matrix onto MorphoBank. A phylogenetic matrix usually contains taxa, character names, character states, and of course the matrix. And there are a couple of additional functionalities kind of put into MorphoBank to be able to get more information for this particular matrix that you're uploading. And so we've partnered up with the Paleobiology Database and NCBI to be able to add more information regarding the taxa that you upload. So let's say your matrix only contains the genus and species name of the taxa that you're uploading. You'll be able to add extra information regarding kingdom, phylum, things like that through our taxon search with PBDB and NCBI. And if you're looking to add a little bit of images to your matrix of the taxa that you have and aren't able to look for the images, well, MorphoBank will do the job for you with our connection to IDIC and Encyclopedia of Life, where you just need to provide all your taxa names and it'll automatically populate pictures of your taxa if there are any associated with the name of your taxa. There's also additional functionalities like creating phylogenetic trees through Cypress, but all of that is just a large function of what MorphoBank is. And then at the end, all the data is then published and made public in order for everybody around the world to access. Since it's open access, it's free to access. And so today I'll only be talking about the data upload aspect because that's the issue that we are currently battling, and that's what the AI-powered solution is for. And so this is the data integration challenge that MorphoBank is currently facing. And so the paleobiology database had about 650 phylogenetic matrices that they weren't able to keep up with on their website. And so they decided to provide these 650 matrices to MorphoBank to make it a more robust data repository and sort of the only data repository that has all the phylogenetic matrices to make it an open access kind of concentrated resource for everybody to have. However, we've battled an issue that all these matrices that are provided by the paleobiology database have the taxa information, have the matrix information, but don't necessarily have the character names and character state information in them. So they're incomplete. So this kind of defeats the purpose of the findable, accessible, interoperable, and reusable aspects of FAIR data. And since we want to provide complete and accurate information as a means to reuse it, we are in the process of completing all these matrices before we ever publish them onto MorphoBank. And so this is a layout of what a nexus file looks like. A nexus file is the computer name for a phylogenetic matrix. It's what encodes a phylogenetic matrix when you upload it to MorphoBank. So I can go over the aspects of a nexus file now. So this is the taxa block right over here. It consists of all the taxa names that are associated with your matrix. Next up is the character names and character state blocks. So this will be where the character names and states go. As you can see, this block currently is empty, and this is how all the paleobiology database matrices look like for us right now. The character block is completely empty and it needs to be populated before being uploaded to MorphoBank. And then at the end is the matrix block. Now, what we really want is the one that I'm pointing at right now is where there's a taxa block. In addition to taxa block, there is a character block, but however, you can see that the character state labels have been completed in this matrix. And I promise you at the end of this Nexus file is a matrix block like this, which marks the file as complete. And so now that you have kind of an idea of what an incomplete Nexus file looks like versus what a complete Nexus file looks like, you'll be able to follow how this AI-powered solution actually works even better. And so before I'd go through the tedious procedure of looking for the empty matrix file, which was provided to us in a Google Drive folder, and then I'd have to look for the paper that's associated with this particular matrix. And that would take a little bit of while. And then the most tedious task of this was the data entry part, where I'd have to manually go in and type in each character name and character state associated with this matrix. And so matrices can easily range from 20 characters all the way to 1,000 characters. And let's say about a 50 character matrix takes 30 to 45 minutes to do manually. That's a lot of time, and it would have taken years to be able to complete the 650 matrix transfer from paleobiology database to MorphoBank. So I came up with an AI-powered data integration solution. And so in the background right here in black, you can see the user interface for the AI that I've created. It's called the MorphoBank PBDB PDF to Nexus file generator. You can see a preview of what a paper would look like that has the character names and character states. And at the very front is what I'd use to manually type in each and every character name and character state. It's a program known as Mesquite, which kind of helps you visualize the matrix on how it actually looks like versus the Nexus file, which is kind of just a bunch of lines of code. And so the AI-powered solution that I created takes in a document containing the character set and asks the user to provide information about the total number of characters and where these characters are located within the paper, so the page numbers. And then we use the advanced natural languaging processing capabilities of a large language model, an LLM, to analyze the document. We are utilizing Google's Gemini 1.5 Flash and 1.5 Pro at the moment, and the LLM intelligently understands the structure and context of the character list, even if it's presented in a complex format. As we all know, science papers can be a bit complex sometimes, and it's sometimes hard for me to understand them as well, but the AI is smartly able to sort of like unravel the mysteries of the scientific paper it's assigned to do. And then our app automatically populates the matrix file with the extracted character data. This means that I can say goodbye to typing it all out on Mesquite and focus on the quantity that I'm transferring over to MorphoBank over having to tediously type each character, check if I've written the spelling right, because at the end of the day, we are looking for accuracy as well, because we want to provide true data to people who are able to reuse it. And so moving on, this is a little bit on how it works. We believe that, again, the solution is to use this AI in order to complete this transfer. And so harnessing the LLM power, the application utilizes advanced LLM language processing capabilities. Now, these capabilities are the fact that we don't have to train it for it to understand the scientific papers. It is so smart in itself that it kind of trained itself when we started using it on these scientific papers. And so after that, I've created sort of a complete toolkit where including text pre-processing for data cleaning, chunking for efficient handling of large data sets. We use count validation for accuracy and LLM evaluation also for quality control and accuracy checks. And the format of the output automatically updates to a format that's accessible to upload onto MorphoBank, because MorphoBank has a stringent kind of policy of what kind of Nexus file it accepts. And I'd also like to plug in the user-friendly experience that the AI is built around, so that the entire process of inserting the character state numbers and the page numbers are all kind of intuitive. And so I'm going to talk a little bit about the text pre-processing feature now that trying to understand a complex research paper filled with tables, figures, and complicated formatting is pretty overwhelming. And so our application tackles this challenge by using intelligent text processing techniques. And as you all know, scientific papers have two columns and they're not read linearly. So we really needed our text pre-processing to not read things linearly. And so we made it in a way that it kind of reads the first column first, how we would instead of reading 1, 3, 2. The text pre-processing reads it 1, 2, 3, which is how a human would read it. And so this makes it easier to kind of extract the data in the right order versus it being in the wrong order and all jumbled up. We also don't stop there. We also apply sophisticated post-processing techniques to clean up the text, where we take out any unnecessary formatting or special characters and other extraneous things that would sort of confuse the LLM and throw off the accuracy of it. And so by delivering like a high quality, clean text to our LLM, we are guaranteed like a nice high quality output. And then we're going to move on to what chunking and sliding windows are. So LLMs are pretty powerful tools, but they do have a finite attention span, just like me right over here. So they can only process a limited number of characters or tokens at once. This can be a challenge when analyzing long and complex research papers. And to address this, we use a technique called sliding windows. We break down the research paper into manageable chunks, each within the LLM's processing capacity, so it's not overwhelmed while it's reading these characters, and each chunk is given to the LLM to extract a certain section of the characters. And so, talking about the validation methods that we use for accuracy, the response of an LLM for each chunk is validated, and we ensure that it's done in a two-step process. One of the steps is pretty easy, while the other one is a more complex step. We can check the number of characters extracted by our LLM against the number of characters that were kind of input in that little state the number of characters that are in your paper entry. And so this helps us catch like any duplicates that might have happened or any missing sort of characters in number. However, we don't stop there. We use a separate LLM to model assess the overall quality and correctness of the extracted data. And so this LLM acts as a second pair of eyes, ensuring that the matrix is sound and accurate. And so any failed chunk in these kind of count validation as well as the LLM evaluation is then reprocessed. And so this two-prong approach gives us the confidence that the results generated by our application are accurate and reliable most of all. Lastly, you must be thinking that this must be pretty slow if it does it linearly and talking about all the chunking that's happening and there's limited processing capabilities in an LLM. But LLMs are slower than traditional computer programs. Now, this is contrary to popular opinion or like opinion that's normal that, oh, LLMs are fast, they're great, but they're actually pretty slow. And so we make use of a parallel API calling for LLM to reduce the time required for data preparation. This way, each chunk of text is processed parallelly instead of linearly. And so think of it as having a team of workers all working on different parts of a project at the same time. This parallel approach allows us to achieve like 10 times, even 100 times the speed compared to a manual human like me doing it. And so this could possibly be the future of evolutionary research because becoming a part of all these workshops that MorphoBank has hosted, I've realized that people do have empty matrices that they need to fill, empty nexus file that only have the taxa block and the matrix block. And I've been able to put them into my AI-powered tool and have output complete nexus files that which were then uploaded onto MorphoBank for the public to see, which is a great deal because it's a great campaign towards having more fair data in the scientific realm. And so I'd like to thank the Third Joint Congress on Evolutionary Biology for my recorded presentation. I really appreciate you guys listening in. I'd like to thank Phoenix Bioinformatics and MorphoBank for having me as an intern, and thank you to NSF for funding MorphoBank as a data repository. If you have any questions or comments for this presentation, please feel free to email me on any of those email addresses. And thank you so much for listening into my talk.